Hello everybody, welcome to our 20th OpenStack online meetup. Today with us is Dmitry Zimain. He is with StackStorm. He actually is the co-founder of the company and the CTO. And Dmitry will talk about automation, automating OpenStack. So he will review the automation projects within OpenStack and how mature they are, and he will also explore appropriate use cases and their likely direction. And with that said, let me head over to Dmitry. Dmitry, the stage is yours.
Hello, everyone. How are you doing? So, as Rafael said, thank you, Rafael, for introduction. My name is Dmitry Zimain, and I've been in the field of data center automation and cloud management for over 10 years now. Now I'm in CTO and co-founder of StackStorm. At StackStorm, we're doing operation automations. We work with OpenStack, we contribute to OpenStack, and I'm personally fascinated with OpenStack phenomena. It is expanding to pretty much reinvent everything that we have in the system software. Well, sometimes it goes overboard, but I believe natural forces and foundation governance will take care of that over time. Well, but the DevOps movement is happening here. The new approaches to automations are tried out here. Interesting projects and services are emerging around OpenStack and within OpenStack. And within OpenStack is what we're going to talk about that. Right, Rafael? So I'll switch to the presentation mode, and please let me know when it works. Can you see it all right? All right, so we'll go over operation automation projects within OpenStack. And that means that no vendor tools, no general open source tools, however popular or relevant they are, just within OpenStack. And within OpenStack is defined as there somewhere in the OpenStack integration pipeline, as prescribed by OpenStack governance. The integrated and incubated projects are clearly defined. Related, however, is someone self-proclaimed, but you usually know it when you see it. So within OpenStack means that it is intended to be officially integrated. And to do so, the project is developed within OpenStack community in OpenStack context and follows OpenStack governance, which usually means it's a Python code in StackForge, the review process with Jared, continuous integration with Jenkins, Zulu, all the machinery of OpenStack, Tempest integration, DevStack integration, Launchpad, Wiki, all the communication is open on OpenStack Dev, all the things you guys know. And that's the project which is run by proper OpenStack rules. So within that, and further filtering out the monitoring space, monitoring projects, logging, within that, we are left with, surprise, surprise, 20 projects under OpenStack which are doing operation automation. So that's going to be mile-wide, inch-deep overview, or like a quick dating station, where all we know is the project name, what it is about, and what's the status in terms of readiness. And the readiness score I use here ranges from a rough idea, implementation and a vision, a roadmap, the pilot, then functional, there is a use case in place, you can get an idea of what the project is doing, and feature complete, it is minimal viable product. Well, software is never complete, but there is something that works and stable enough to try in your pilot. Production used, something that we've seen in the live clouds used by anyone else, by the original development team. So by anyone else is the key here. And then integrated is officially blessed by OpenStack governance. So It is still entirely possible, like it's almost definite, that I missed 1 or 2 projects here. One may be just created as we speak. Or I missed or messed up some important facts about the project. So please help me out, use the chat, connect to me later, and let's help us fill up this map, all right? With that, let's get going. So I split them to 2 groups. One is that deploy in the cloud, install, upgrade OpenStack Cloud and bare metal. Another group is deploying the workloads, provision virtual machines, group of virtual machines or applications on OpenStack Cloud, and day 2 management automation. So all the tools that keep the cloud and the workload up and running. Deploying the cloud. The first project here is a Crowbar. It is one of the first open source development tool framework. The original Crowbar has been done by Dell as an OpenStack bare metal installer. It's a Rails application that does service discovery, provides firmware updates, installs basic operation system via Pixie boot, deploys OpenStack components via Chef. There is an re-architected Crowbar version 2, as known as Open Crowbar. And this is the transition from pure installer to the tool that manages upgrades, continuous deployments, and some ongoing operations. It's no longer hardwired to Chef and can use some other configuration management tools, and it's technically made to apply it to deploy in virtual machines and containers. Crowbar is an exception. It's not. It is not an official OpenStack project any longer. I brought that here as an exception out of historical respect, as it was there with OpenStack before many of the OpenStack governance rules. So it is used, it is functional, it's mature, but it is substantially less popular nowadays. Rumors have it that Dell is pulling the plug on Crowbar, but this is something that I cannot officially confirm, so just keep your ears open to that. Fuel. Originally, it was Miranti's proprietary solution. In 2013, it has been open sourced and contributed to OpenStack. Fuel is an orchestration layer. It sits on top of Puppet, mCollective, Cobbler. It takes all the Mirantis' best practices of OpenStack deployment and codifies them. Like all the other tools in this category, it does hardware discovery, network verification, OS provisioning, and deploys the OpenStack components. Fuel has a very nice UI, and an interesting thing is you can play with this UI on this URL, so they expose that. Try it out. Status, it's pretty mature. It has been used by Mirantis a lot. We had seen that in the field. New people usually try that because they're attracted by the ease of use to get the cloud deployed. And Mirantis consultants brought Fuel into some large production deployments. Next in the category is Compass. Compass is yet another OpenStack deployment tool built by Huawei for their specific needs and open sourced as OpenStack related project in January 2014. Compass developers position it as simple, extensible, data-driven platform for deployment not limited to OpenStack. There is a thin layer, and it leverages other tools for hardware discovery, hypervisor deployment, configuration management. It's OpenStack related. Apparently, it is used by Huawei. I haven't seen that used in the field by anyone else yet. Lastly, TripleO. TripleO is very unlike the other components. And TripleO installs, upgrades, operates OpenStack Cloud using OpenStack itself. It's mind-bending. It takes OpenStack to deploy OpenStack. In essence, O is a dedicated OpenStack installation called the Undercloud that is used to deploy other OpenStack clouds, overclouds, to bare metal. So the desired overcloud is configured as a heat template. Deployment is orchestrated by heat. The nodes are provisioned on bare metal using Ironic. It pixie boots the machine, installs the images with OpenStack components. The images are dynamically generated with Disk Image Builder from image elements. So you can build the element which contains series of controllers all together and deploy them. The beauty of that is OpenStack operators use familiar OpenStack tools. So it's Keystone Authentication, Horizon Dashboard, Nova CLI. All the tools that you use against the OpenStack will work for OpenStack deployments. AAA target large-scale deployments. They actually say that the small deployment is solved and problem by other tools. And the sweet spot for that seems to be the continuous integration and continuous deployment of multiple involving OpenStack clouds to hardware. So in terms of status, OO is officially integrated project. There is a lot of traction in OpenStack community, big support from Red Hat, HP, other significant ones. I think it's a long way, it's a way to go. The readiness status on that is a big question mark. On the other hand, on the one hand, it is officially integrated. Notably, it is used by HP Helion Cloud as a deployment tool. On the other hand, Wiki and all the documentation claims that it is functional but work in progress. And it's not seen in production or even proof of concepts that much. So after talking to developers, my impression that it's going to be ready for prime time, probably in K-cycle, some spring 2015. Here are smaller tools for completeness. DevStack, everyone knows that. Backstack is a utility that sits on top of Puppet models and deploys the OpenStack via SSH. Surprisingly, this is used a lot. According to the OpenStack user survey, this is number 4 after Puppet, Chef, and DevStack. Number 4 deployed tool. So there are a few others just for the completeness. Moving on to deploying workloads. Here come the tools to bring the workloads, virtual machines, virtual appliances, and or applications. Heat, this is the service to define the stack of resources in the plate and orchestrate the deployment and lifecycle. You know, unless you lived on a rock or your first time on OpenStack meetup, you know Heat. And many of you probably know what Heat is doing better than I do. That's one of the hottest projects in the OpenStack automation ecosystem. So I'll just describe that a little bit more. With Heat, user defines a virtual infrastructure stack as a template and simple YAML file describing resources and their relations like servers, volumes, floating IPs, networks, security groups, users, etc. Given this template, Heat orchestrates the full life cycle of the complete stack. It provisions the infrastructure, makes all the calls to create all the parts and wire them together. If you want to make changes, then you modify the template and update an existing stack. Heat knows how to make the right changes. When the stack is deployed, the Heat deletes all the allocated resources with this. Heat supports autoscaling. A monitoring event like Celometer alert can trigger the scaling policy. Then Heat provisions extra instances into an autoscaling group. Since Icehouse, Heat also supports software configurations. User defines what the software should be installed on this instance, and then Heat weaves all the deployment and configuration into the instance lifecycle. Say, When you pause that, you restart the instance, it doesn't need to rebuild the whole instance, it just rebuilds the configuration part. Heat is capable of integrating with the configuration management tools like Chef and Puppet. Well, an interesting thing about Heat is it also is a service component for other OpenStack services. We mentioned OOO, so OOO is using Heat as a deployment orchestration service. Solum, we'll be talking about that, will be using Heat. Many other projects use or consider using Heat when it comes to defining the template and orchestrating and creating or something. Again, this is integrated. Heat is maturing. It is a very strong community behind that. It's used in the field by OpenStack survey. It's actually seen at about 10% of deployments. Opinions split on Heat. Some people think that Heat is the best thing since sliced bread. Some think that Heat is a disaster. I do not cast my opinion. I just think that I'll bring this controversy to your attention. Solum. This is the platform as a service for developers. Application delivery platform like just like Cloud Foundry or Heroku. In fact, Solum supports Heroku and Cloud Foundry artifacts, but it is natively designed for OpenStack. Solum deploys the application from a public Git repository, and it gets that to OpenStack Cloud to different language runtimes. A YAML plan file describes the topology of the application, the runtime, and the services the application will need. A service add-on framework will provide services for the application to use, like MongoDB, Memcache, New Relic, etc. Really similar to what you get in Heroku and Cloud Foundry. Solum pushes the application through the continuous integration pipeline. So it gets that from the source code, builds unit tests, creates the image, stores this image in Glance, then runs the functional test, and eventually deploys that to the production using a Heat template. Solum leverages many OpenStack projects. It leverages Heat, Nova, Glance, Neutron, and Mistral. Over time, Solum will also guide and support developers through the development to test to release cycle. It will support rollbacks to the previous version, will support monitoring, manual and auto scaling, and all the other good stuff. As of readiness, Solum is very young. It is announced and started at Hong Kong Summit. By Atlanta Summit, it only knows to do one very basic development pipeline. Most of the features I mentioned are on the roadmap for 2015. However, it has a very well-run community, very strong marketing, by the way, very strong team, and solid support from Rackspace, Red Hat, and a few significant others. So I would keep an eye on that. Murano. Murano is an OpenStack self-service application catalog. It targets the cloud end users, including the less technical ones. If you're familiar with traditional enterprise service catalog applications like VMware vCake or IBM Tivoli Service Request Manager or the likes, that's about what Murano is. So Murano provides a way for a developer to compose and to publish a high-level application, say like Microsoft SQL Server or Postgres database. It is anything from a single virtual machine to more complex multi-tier application with some auto-scaling. Murano provides a YAML-based language to define such an application, and it offers an API and the user interface for the developer to publish that to the service catalog. Then end users got to the service portal, they browse the catalog, within the categories, select the application they like, and get this application provision into them with just a push of the button. Murano is OpenStack related project. It is likely to apply to incubation. It has been first released in May 2013. By now it is functional and apparently pretty stable. Murano has been already used in the field, as far as I know, brought by Mirantis and customized by their professional services. Especially it's used and it especially attracts the customers who need Windows-based environments. I'm not aware of anyone trying Murano by themselves, but OpenStack is a big community. I might be mistaken. Day 2 operation automation. This is maintaining and managing the cloud and workloads, keeping it all running. This is a broad area, responding to all the hardware failures, application performance degradations, troubleshooting, reactive and proactive maintenance, all the other often boring, often mundane tasks that we really want to automate, to spend the time on the creative work. This is a wide area, but the projects here are only emerging now, and most of them are very young. Some of these projects, like Rubick, Blazar, Satori, are solving specific narrow use cases, and other Mistral Congress are more general-purpose automation tools. Let's look at them one by one. Blazar, it used to be called Climate, it addresses a particular pain point of most corporate private clouds. There is no incentive whatsoever for the users to return resources. It's a big pain point, and the typical solution for that is introducing the concept of lease and scheduling. So Blazar manages the lease of cloud resources. It might be virtual resources or physical resources. It can schedule using the resource in the future. It negotiates the lease term between the user and the system. Then it automates the process of allocating and releasing the resources and provides visibility to the resources which are consumed. Nova and other services must be aware of the lease concept. So Blazar introduces Nova filters and Nova API extensions for lease in scheduler. So readiness, that's pretty early. With basic functionality in place, currently it implements reservation of virtual instances and physical hosts. It has pluggable architecture for more resource to come. It probably will be applying to incubation soon. Rubick is a diagnostic tool. Rubick inspects and validates OpenStack cloud configurations for correctness and consistency, and then it reports any errors and misconfigurations. How it does that? It auto-detects the OpenStack cluster, which is pretty neat technology. It then extracts the actual configurations of OpenStack components like Keystone, Cinder, Nova, and Center, and check them against the rule set to validate their consistency and correctness. There are two types of rules there. Some are simple syntax checks of the configuration parameters. Other rules are more complex. That's actually the code that runs and inspects the entire model to find some inconsistencies across OpenStack components. There is a simple UI that walks you through the process of discovering the OpenStack and validating, and then this UI reports all the errors and warnings. Fixing misconfigurations is not in Rubick implementation, so it only reports the misconfiguration. Rubick is OpenStack related project. It is functional, it is complete, but it is not widely adopted. And I think what drags Rubick adoption is the content. It requires the rules and the configuration checks to be up to date with the projects. So it must be the other projects in the community that writes these checks. And the community must jump on creating the rules. But as of now, it doesn't. And there are very few interesting rules in the Rubick out of the box. So it pretty much checks the configuration file, and even that is difficult to be to stay up to date. So we'll see if community jumps in here. Satori provides configuration discovery for existing infrastructure. You give Satori a URL and some credentials, and it discovers the resource behind this URL. It figures out the role of this resource, figures how this resource is related to the OpenStack cloud. Say it will say it is a web application running on the Nova instance, which is connected to this Nova host and so on, or it says this is the Cinder control node. Then it lists all the services which runs on this service. With the pluggable implementation on the roadmap, Satori will eventually discover non-OpenStack infrastructure like API for other clouds, nodes in Chef server, operating systems, application topologies, and all the other stuff. Conceptually, it is similar to discovery tools like Ohai and Factor from Chef and Puppet, and it actually leverages these tools, but it adds OpenStack awareness to it. Satori is a very young product. It started in 2014. There is a first POC. It looks like they have a vision. We have the first implementation. We'll see where it's going. Congress. This is a really interesting one. I like it very much. So Congress is generic policy monitoring and enforcement framework. It monitors the set of cloud services for policy compliance, and then it applies corrective actions when violations are identified. It can even prevent violations from happening in the first place when possible. So conceptually, it does that by by cloud service consulting with Congress, but practically, it's more complex than that. It's a little bit more interesting. So the policies are declared in data log. Data log is a language which takes a little bit getting used to, but when you know that, it makes perfect sense. And Congress uses data providers to connect with cloud services, fetch the relevant data, keep them up to date, and execute the corrective actions. The beauty of Congress is it is independent cross-domain framework. So the Congress overcomes the limitation of domain-specific policy enforcement efforts. Many of the, especially notable in networking projects, have the policies going on already, but Congress is capable of handling the cross-domain policy. Something like every network attached to a VM must be a private network owned by someone in the same group as VM owner. So as you can see, this rule requires the policies which touch Nova, Neutron, and Keystone. So status, it's early. It has very well thought out design and a great vision. There is an early implementation. It's not fully functional. It has basic architecture. It has policy language support and rudimentary plugins for Nova and Neutron right now. To be successful, it will need a buy-in from OpenStack projects, so that the OpenStack projects provide their own plugins for policy monitoring and enforcement. But I think it, if it takes off, it will be a very, very interesting thing. Mistral. Mistral is a workflow service for OpenStack cloud automation. Workflow-based runbook automation done right, as I call it. A workflow is a sequence of tasks with transitions and conditional logic. In Mistral, it is expressed as YAML-based definition. The workflow can be triggered on demand, on scheduler, or on a monitoring event. Then Mistral runs workflows at scale with high availability and resilience. It executes the task actions, keeps the workflow state, carries data between the tasks. Mistral offers extensible set of actions. SSH, REST, HTTP call, email, OpenStack pack, they're coming out of the box, but you can write your own actions and stitch them together in a workflow. A basic UI is available today as a Horizon dashboard, a visual representation of the workflow plan, and workflow execution is on Mistral roadmap. Mistral targets cloud automators so that they use workflow for automation their operational procedures. They use workflow to integrate across cloud components, integrate different cloud services with their business processes, like Jira or human intervention. Then application developers can leverage Mistral as a workflow service, similar to what is done in Amazon Simple Workflow. Mistral is also a platform component for other OpenStack services. Many of them need the concept of the workflow service. Solum, Fuel, Barbican, Murano, Keystone, Trove, Congress, and some more are looking at integrating with Mistral. Status. Status. So Mistral is new. It was introduced in Hong Kong. The pilot was done by Atlanta. Many functionality is, like all the main functionality is in place. Mistral team now is refactoring some of that, but it's pretty good, solid functionality. StackStorm is contributing to Mistral. We know from our experience that a workflow service is a key component to any holistic automation solution. That's why we're here. In summary, well, that's a long potpourri of the projects. Like, what's the summary of that? Is, well, cloud deployment, that's a solved problem. Any of the projects we mentioned here, and many outside of pure OpenStack umbrella, can do cloud deployment very well today. Workload deployment. It's actually few projects there. It's interesting. And the reason behind that is many products and solutions are outside of OpenStack. Mostly the workload either developed by Cloud Foundry or proprietary solutions. I want to mention Tosca here. It's an emerging standard that for cloud definition, for cloud application definition, and more solutions and more projects are looking at Tosca and conforming to Tosca. So many products and solutions outside of OpenStack, but Heat is here to stay, and I think Solum is very interesting to watch. For day 2 automation, this used to be a known field before cloud and DevOps changed the landscape. Now the old approaches no longer work, and the new approaches has not quite established. So this is the area where I expect to storm the most. There are many different approaches coming up, some competing, some complementary. The jury is still out of what's the right way to do the day 2 automation. So it is not appropriate to talk about the customer solutions here, so we're not talking about StackStorm in this context. But if you want to know more about how StackStorm thinks of automation, if you want to know more about our vision and our learning in the automation space, please welcome to join us on the event, which is going to happen next week, July 22nd and July 24th. Check it out, stackstorm.com at News and Events. There is a link to this event, and we'll tell you more with this. Thank you, and let's see if we have any questions.
Dmitry, thank you very much for this awesome and impressive presentation. I wasn't really aware that there are so many different automation projects available for OpenStack. We don't have any questions as for now. Neither through IRC nor through Twitter. So I see that 28 people are with us. So just in case that you have any questions, feel free to ask them either through the OpenStack community IRC channel, which is hashtag OpenStack #community, or via Twitter. Our Twitter handle is OpenStack_OM, which stands for Open Online Meetup. So let's wait, Dmitry, maybe a couple minutes. If questions come in, feel free to answer them. If not, let's end this session. And maybe if people have any questions once they watch the recorded session, we can follow up with them.
Yeah, and my email is dz@stackstorm.com, and I'm welcoming any questions or any suggestions or any corrections or additions to this overview. I must say that when I looked at that first, I myself was really surprised by the number and variety of the projects in automation, and hopefully I managed to share my excitement about this area.
You actually did. Well, there are no questions coming in, but maybe, well, there's one question. Someone's asking, would like to hear more about StackStorm. Let me see if maybe a preview of what's planned for next Tuesday. Oh, okay. Can you talk about that?
I prefer not. I prefer keep that as a surprise, but I really invite you to join our presentation next Tuesday. That would be let's go StackStorm/news and events. Roughly speaking, we're doing operation automation, and we are believing in the closed loop automation. So we are closing the loop between the monitoring tools and the management tools, and adding intelligence into the automation.
All right, so we're very excited to see those, or to join and see those meetups that you're planning, that you've scheduled. Dmitry, thank you very much for the presentation. Thank you very much, and thank you everybody for joining us. And see you soon.
Thank you, Raphael. Thank you, everyone.